The furthest galaxy we have ever observed is located 32 billion light-years away from Earth. Take a second to let that number sink in. That single fact is probably the most terrifying thing in modern science. Light from that galaxy began its journey to us in a time when our planet didn't even exist. Back when the entire solar system was just a cloud of cosmic dust spinning in the infinite, freezing dark. That light traveled through the void for over 13 billion years. And during that entire time, the space between us and that galaxy was stretching. Right now, as you are hearing these words, that galaxy is moving away from us at a speed that exceeds the speed of light. It is already beyond our reach, forever. We will never be able to send a signal there. We will never know what is happening there at this very moment. And that is just one of the countless galaxies disappearing from our reach every single second. We like to think that the cosmos belongs to us. We tell ourselves stories about how, one day, we'll build ships capable of crossing interstellar distances. We dream of colonizing other solar systems, then other galaxies, believing that the universe is waiting for us with open arms. But that is an illusion. It's a beautiful, comforting lie we tell ourselves so we don't feel so small, so powerless, and so incredibly alone. Truth is much darker. Today, we are diving into the existential crisis of our civilization. We're going to look at the invisible forces already working to separate us from the rest of the universe, forever. Let's start with what most people believe. The official version taught in schools is that the universe is huge, but not impossible to conquer. Sure, the distances are colossal, but technology is evolving, right? We think we'll build generation ships, or use cryogenic sleep, or find a way to warp space-time. We are humans. We always find a way. We mastered fire. We split the atom. We landed on the moon. But the very structure of reality was designed to keep us in our cage. The universe isn't just vast. It is actively working against us. When you look at the night sky, you see thousands of stars. It feels like the cosmos is full of destinations. But here is the first shocking fact. Almost every single star you see with the naked eye is within a radius of about 1,000 light-years. That sounds like a massive distance, until you realize that our own Milky Way galaxy is 100,000 light-years across. You are seeing less than 1% of 1% of our home galaxy. You are living in a tiny bubble in an ocean of stars. And remember, our galaxy is just one of 200 billion galaxies in the observable universe. The scale is so massive that the human brain simply refuses to process it. Let's look at the nearest star, Proxima Centauri. It's 4.2 light-years away. In kilometers, that is about 40 trillion. To understand how far that is, look at the fastest object humanity has ever built, the Parker Solar Probe. Travels at an incredible 700,000 kilometers per hour. At that speed, you could circle the Earth in less than 3 minutes. But how long would it take that probe to reach the nearest star? 6,000 years. 6,000 years. If we sent a ship today, by the time it arrived, 200 generations of humans would have passed on Earth. Entire civilizations would have risen and fallen. The languages we speak today would be dead and forgotten. And that is just the nearest star, the easiest point to reach. To find a planet that could actually support life, we'd have to go dozens or hundreds of light years further. Even with sci-fi technology, we're talking about journeys lasting thousands of years. Generation ships sound exciting, but they require closed ecological systems that work perfectly for centuries. No man-made system has ever functioned without failure for more than a few decades. One small glitch, one social conflict, one mechanical failure, and the entire mission is a graveyard. We are talking about hundreds of generations born and dying in a metal box, drifting through a void they don't even understand, with no guarantee they will ever see a sun. We are trapped by distance, and as we are about to see, distance is only the first wall of our prison. Even if we managed to solve the problem of distance, if we built the perfect ship and mastered the art of freezing time for the crew, we would still slam face first into the most unforgiving wall in existence. We are talking about the speed of light. In the world of science fiction, the speed of light is just a starting point. Captains shout an order, stars stretch into lines, and suddenly we are halfway across the quadrant. But in the real world, the speed of light, about 300,000 kilometers per second, is not just a speed record. It is the absolute, final, and unbreakable limit for any information, matter, or influence in our universe. This isn't a technological hurdle that will eventually clear with enough engineering. It is a fundamental property of space and time themselves. Einstein's special relativity isn't just a clever theory. It is a verified fact that we confirm every time we use a GPS or run a particle accelerator. Here is the brutal physics behind it. As you accelerate an object closer to the speed of light, its relativistic mass effectively begins to increase. It's not that the object physically gets bigger, but it becomes harder and harder to push. To get an object with even a tiny amount of mass to move at 99% of the speed of light requires a colossal amount of energy. To reach 99.9%, even more. But to actually hit the speed of light itself, you would need something that simply does not exist: infinite energy. Think about that for a second. Infinite energy just to move a single atom at the speed of light. This means that for a physical spaceship, c, the speed of light, is a horizon we can approach, but we can never, ever cross. We are literally hardwired into a universe where the maximum speed is fixed, and that speed is agonizingly slow compared to the size of the cosmos. But what about the cheat codes? What about the Alcubierre drive? The famous warp drive? In the 1990s, physicist Miguel Alcubierre showed that you could mathematically warp space, contracting it in front of a ship and expanding it behind. Technically, the ship isn't moving faster than light. The space itself is being manipulated. It's the ultimate loophole. But there's a catch, a massive, planet-sized catch. To make a warp drive work, you need something called exotic matter with negative mass. We have never seen this stuff. We have no proof it even exists in our physical reality. It's a mathematical curiosity that doesn't necessarily translate to hardware. And even if we found it, the energy required to create that warp bubble is so vast it would literally require the mass energy of a whole planet just to move a small vessel. The same goes for wormholes. They are theoretical tunnels through space-time, but they are inherently unstable. Keep one open for even a millisecond. You would again need that mysterious negative energy to prevent it from collapsing instantly. And if a human ship ever tried to enter one, the tidal forces, the difference in gravity between the front and back of the ship, would likely shred the craft and the crew into subatomic dust before they even reached the other side. The reality is far less romantic than Hollywood portrays it. There is no known method, no secret physics, and no experimental evidence that suggests we can ever travel faster than light. We are staring at a very simple, very brutal truth. We are prisoners of physics. Even if we build a city on Mars, even if we spread across our solar system, we will still be confined to a tiny corner of a single galaxy. But here is where it gets even darker. We've been talking about distance and speed as if the universe is a static map, a giant, quiet room where the furniture stays in one place. But the universe isn't static. It's growing. And it's growing faster than we can ever hope to move. Imagine swimming toward an island in the middle of an ocean. You're a strong swimmer, and you're sure you'll eventually get there. But then you realize, the water between you and the island is expanding. New ocean is being created every second, pushing the island away faster than you can swim. You're not getting closer. You're getting further away, no matter how hard you fight. This is the hidden force that is building invisible walls around our civilization right now. Space itself is stretching, creating new emptiness between us and the stars. In our next part, we're going to look at the discovery that changed everything, and why the very fabric of the cosmos is working to make sure we stay exactly where we are. Up until now, we've been talking about the universe as if it were a giant, static room, a place where the furniture stays in one spot, and the only problem is that the room is just way too big for us to cross. But the reality is much more terrifying. Imagine you are swimming in the middle of a vast ocean, trying to reach a distant island. You're a strong swimmer, and you're convinced that with enough time and stamina, you'll eventually feel the sand beneath your feet. But what you don't realize is that the ocean itself is expanding. Every second, new water is being created between you and that island. Even if you swim as hard as you can, the island is moving away from you faster than you can move toward it. This isn't just a metaphor. This is the literal state of our universe. In 1929, an American astronomer named Edwin Hubble made a discovery that shattered our understanding of the cosmos forever. He was looking at distant galaxies through a massive telescope in California and noticed something strange. The light from those galaxies was shifted toward the red end of the spectrum. We call this redshift, and it works exactly like the sound of an ambulance siren. When a siren moves away from you, the sound waves stretch out and the pitch drops. Light does the same thing. When a galaxy moves away, its light waves stretch, and the light becomes redder. But the real shocker wasn't just that galaxies were moving away. It was the relationship between their distance and their speed. Hubble found that the further away a galaxy is, the faster it's receding. He turned this into a formula we now call Hubble's law. Current value, known as the Hubble constant, is roughly 70 kilometers per second per megaparsec. To put that in plain English, for every 3 million light-years of distance between us and a galaxy, space is adding 70 kilometers of brand new emptiness every single second. If you go far enough out, that math eventually produces a speed that exceeds the speed of light. Now, you might be thinking, wait, didn't Einstein say nothing can go faster than light? And you're right. But here's the loophole. The galaxies aren't actually traveling through space at those speeds. Instead, the space between us and them is stretching. Imagine an ant on the surface of a balloon being inflated. The ant can only walk so fast, but if you blow into that balloon hard enough, the points on the opposite side will move away from the ant faster than the ant could ever hope to walk. The rubber itself is expanding. For a long time, we thought gravity might eventually win this fight. We thought the collective pull of all the stars and galaxies would eventually slow this expansion down, like a ball thrown into the air eventually slows down and falls back to Earth. But in 1998, everything changed. Two teams of astronomers were studying a specific kind of exploding star, Type 1a supernovae. These are standard candles because they always explode with the same brightness. By measuring how dim they look, scientists could tell exactly how far away they were. What they found sent a shockwave through the scientific community. The expansion of the universe isn't slowing down. It's accelerating. Something is actively pushing the universe apart, and it's getting stronger. We call this mysterious force dark energy. We don't know what it is. We can't see it, and we can't measure it directly. But we know it makes up 68% of the entire universe. It is an intrinsic property of space itself. Every cubic meter of empty space contains a tiny amount of this energy. As the universe expands and creates more space, it creates more dark energy, which causes even more expansion. It's a runaway feedback loop that we are powerless to stop. This brings us to the most depressing boundary in physics: cosmological event horizon. Right now, there is a sphere around us with a radius of about 16 billion light-years. Everything inside that sphere is theoretically reachable if we started moving at the speed of light today. But everything outside that line is already gone. Because space is expanding so fast out there, the light from those galaxies will never, ever reach us. It doesn't matter if we wait 1 billion years or 1 trillion years. That light is fighting an uphill battle against an ocean of space that is growing faster than the light can travel. Here is the heartbreaking reality. Every single second, roughly 20,000 stars slip past this invisible line. 20,000 suns, possibly with their own planets, their own oceans, and maybe even their own civilizations, are disappearing from our observable universe forever. They aren't dying. They're just being pushed behind a curtain of infinite emptiness. We are witnessing a cosmic great fade. Out of the 2 trillion galaxies we can currently see, 99% are already unreachable. We are trapped in a shrinking bubble of light, surrounded by a wall of void that is growing thicker every moment. And as we move into our final part, we'll see how this ends, and why future generations may live in a universe where the stars themselves have vanished. So, where does this leave us? While the rest of the universe is screaming away behind invisible walls of expanding space, our immediate neighborhood is actually preparing for a final, grand reunion. Even though dark energy is tearing the cosmos apart, gravity still rules the local scale. Right now, the Andromeda Galaxy is hurtling toward us at over 200,000 miles per hour. In about 4.5 billion years, right around the time our sun begins its own death throes, the Milky Way and Andromeda will collide and merge into one giant, Messier elliptical galaxy. Scientists sometimes call this future home Milkomeda. For any life forms living then, the night sky will be a spectacular show of merging star clouds. But that beauty comes with a tragic price. By the time this new supergalaxy stabilizes, dark energy will have pushed every other galaxy in the universe beyond our event horizon. Cosmic Web will be gone. Astronomers of the distant future will look up and see nothing. No other galaxies. No red-shifted light from the edges of space. No cosmic microwave background radiation. It will have been stretched so thin that it becomes completely undetectable. Future civilizations will live on a lonely island of stars, surrounded by an infinite, absolute blackness. They might conclude that their single galaxy is the entire universe, a solitary spark in a dead void, never knowing the majestic scale of the cosmos that we are lucky enough to witness today. And then, the long, slow fade begins. We are currently living in the stelliferous era, the age of stars. But the supply of hydrogen is finite. In about 100 trillion years, even the longest-lived red dwarfs will flicker out and die. The galaxy will grow cold and dark, populated only by the cooling husks of dead suns, white dwarfs, neutron stars, and black holes. Eventually, even the black holes will begin to leak away. Through a process called Hawking radiation, they will slowly evaporate over spans of time so long the human mind cannot even name the numbers. We are talking about a googol of years, a one followed by 100 zeros. When the last black hole vanishes in a final, silent pop, the universe will enter a state of heat death. Total entropy. No light, no heat, no movement. Just a perfectly uniform, frozen vacuum stretching into infinity forever. It sounds like a nightmare, doesn't it? A story of a grand journey that ends in a locked room and total darkness. But there is another way to look at it. If you imagine the entire history of the universe, from the Big Bang to the final heat death, as a single calendar year, then the entire history of human civilization doesn't even take up the last second of December 31st. We are a flash of lightning in a summer storm. But we are a flash that knows itself. As Carl Sagan famously said, we are a way for the cosmos to know itself. The atoms in your body were forged in the hearts of stars that exploded billions of years ago. You are star stuff that has become self-aware. You are the universe looking into a mirror and asking, "Who am I?" The fact that we are trapped in our tiny cosmic corner doesn't diminish our importance. It amplifies it. The distances might be too vast to cross, and the walls might be closing in, but our minds can travel further than any starship. We can build telescopes that look back to the dawn of time. We can write equations that describe the hearts of black holes. We can send out probes like Voyager, carrying our music and our greetings on golden records, a message in a bottle thrown into a restless, dark ocean. Those probes will outlive our sun. They will be the final evidence that on a small blue dot, in a quiet corner of a fading galaxy, there were beings who dared to look up and dream. So, tonight, when you look at the stars, don't feel small. Feel lucky. You are living in the golden age of the universe, a brief window when the light of 2 trillion galaxies is still reaching our eyes. We might be prisoners in a vanishing cage, but for now, the view is absolutely breathtaking.